you go to eg.poly.edu, click on Writing Consultants, on that list of links on the left-hand side, you'll find a terrible picture of me and my email address there as well. So you can find it there as well. Peter.
So good afternoon. Thank you for coming today. Hopefully you will learn a lot about how to write lab reports during this session. For attending this session, for those of you who have not already read on the website, you do get the opportunity to rewrite Lab 1. So a lot of students have asked me, what is the deadline for this report? The deadline is at Lab 7. So essentially this rewrite of the report will take the place of Lab 6. So Lab 6 would normally be due the night before your Lab 7, right? So that's when, whenever you guys have lab, that's when it's due, okay? Does anybody have any questions about that? Yes? There's no report for Lab 6 because Lab 6 is your first model shop session. Yes? There is a slot available for Lab 6 on the website. The question was, how do you submit the rewrite? You submit it as Lab 6. Any other questions? All right. Oh. By rewrite, do you mean by just fix the mistakes?
Well, if it was me, I would read my comments that I made on your lab report, and I would read the TA comments that were made on your lab report, and I would review this PowerPoint presentation, and I would rewrite accordingly. There may be material in your existing Lab 1 report that's quite good. You may have some deficiencies in other places. So you want to keep the stuff that's good, and you want to correct the stuff that you got points taken off for. Right? I saw a hand somewhere. Yes? Correct. Any other questions? Okay, let's begin. So this is a PowerPoint presentation, obviously on how to write a lab report. And it speaks specifically to the content of the first lab report, the hot air balloon lab that you performed in this course. So the first thing that I want you to understand is I want you to look at your lab reports as a form of storytelling. Right? It's a single story that you're telling from start to finish in the lab report. And it's science writing as storytelling. There's a book by a gentleman by the name of Keith Hortshoy, The Transition to College Writing. And this is how he characterizes the various sections of college lab reports, right? What were you doing and why? How did you do it? What did you find out? What do the results mean? So these are sort of generally the questions that should inform what the various sections in your lab report are about. This doesn't correspond exactly to your lab reports in this class, but it's similar. So that gives you a sense of what we're looking for in your lab reports. These are the major sections. All of you should know this by now. You should have all of these sections in your lab reports. And you should have section headers in the lab reports. And I strongly suggest, if you haven't figured it out yet, that you create a template for yourself that includes these section headers. And you don't have to rebuild the template every time you write a new lab report. The thing already exists and you just plug in the information and the text in the appropriate sections. So I strongly recommend you do that. You can do it for your PowerPoint presentations as well. So you're not recreating those documents every time you have to do a new PowerPoint or you have to do a new lab report. So this is the abstract. It's a summary of the report, so you would write it last. You cannot summarize something that you have not created. You have to know what the report says to summarize it. And so this summary, this abstract, assumes that there were 3 hot air balloons in this competition. And as you can see, the first paragraph is the objective right here. Right? It tells you that it was a competition. It tells you how it was judged. The second paragraph is how the hot air balloon that is the subject of this report performed on its 2 trials and how it placed out of the 3 balloons in the competition. Then it gives you the greatest ratios for the first place hot air balloon and the second place hot air balloon. To understand a competition, you have to know how every competitor performed, right? Anybody here follow soccer, baseball, football, basketball, swimming, on and on and on, right? If I tell you only how one competitor performed in a competition. I have not told you what happened in that contest. You have to know how both baseball teams performed, how both football teams performed, how both soccer teams performed, how every swimmer in 6 lanes in a swim meet performed to know the results of the competition. So you've got to have all 3 competitors identified here by the one piece of information that decided the competition. Don't put all your data in your abstract, just the major data, and in the case of a competition lab, that's the one piece of information that determined the results of the competition. Everybody get that? Okay. So now the introduction, we tell you in the manual, should be a minimum of 3 paragraphs long. If it's shorter than that, you've probably made a mistake and you need to revisit it and perhaps write some more. It's not a hard and fast rule, but it's something to keep in mind when you're writing your introduction. So these are the sorts of things that you would discuss in your introduction. You might want to comment on the NASA balloon program. I got to tell you, from my perspective, we're much less interested in the Montgolfier brothers and much more interested in what's current when we're talking about the technologies that we're discussing in the lab report. So if you don't discuss the Montgolfier brothers in the lab reports in my sections, I don't care. I would expect you to discuss the NASA balloon program. Right? I would expect you to discuss the ideal gas law, the Archimedes principle, obviously that's buoyancy, then any formulas that you used. If you looked at the formulas that we have in the manual in your report, I would expect you to discuss those here. Then because it's a competition lab, I want to know the rules, the ratio that determined the rankings in the competition, and then the final paragraph should be your design strategy. How did you take all of this information and how did you implement it in your balloon with an eye towards winning the competition? Now, here's something to bear in mind about this. I will typically see students say in a lab report like this that the strategy was to maximize payload, maximize time afloat, and minimize cost. Now, sometimes that's true, but you've got to look at your own data, because if you performed a lab in which the most expensive hot air balloon placed first, because it had the highest payload and the highest time afloat, you really can't assert that as a design strategy because your own data is saying that's incorrect. So always check your data before you make an assertion like that any place in the lab report, because your data might say, well, that isn't true. You know, the balloon with the highest cost won. So attend to that kind of thing when you're putting your introduction together. So this would be sample text. Obviously, this is not a complete introduction because, as you can see, it's only 2 paragraphs long. But this is an example of what an introduction might look like. It's a mix of tenses. When you're talking about what you did in the lab, that's in the past tense. Otherwise, it's going to be a mix of tenses. If you're discussing something that's always true, say the definition of buoyancy or the definition of the ideal gas law, you must write that in the present tense. You can't make those things untrue by writing them in the past tense. Everybody follow what I'm saying there? So things that are always true are written in the present tense. I just want to quickly go back here. Abstract, past tense, introduction, a mix of tenses. And so here's just a sample text that you might want as sort of the beginning for your introduction. Introduction should be organized from the general to the specific. So here you're talking generally about lighter than air aircraft, hot air balloons, what their current uses are. Then you turn to the ideal gas law, the Archimedes principle. Then you would want to start to talk about the rules, the ratios, your design strategy. And then finally the design strategy is the final paragraph. So that's how you'd want to organize this thing, from the general to the specific. All of your introductions should be organized that way. Next is the procedure section. Also written in the past tense. Every sentence in this section is written in the past tense. The essence of this section is repeatability. It should be sufficiently complete so that I could follow your description and replicate your results. Everyone here know what a peer-reviewed journal is? Anybody not know what a peer-reviewed journal is? Okay, so a peer-reviewed journal in all of the sciences and in engineering, engineers and scientists communicate with one another through a peer-reviewed journal. They'll do a study, They'll produce a body of data from that study. They'll believe that that is significant information. They'll write an article. They'll submit it to a peer-reviewed journal. Peers, other scientists, other engineers in that field will review it, and they'll say, yes, this is important, or no, it's not important. If it's approved for publication, it goes through a whole series of edits and modifications, and then it gets published. So it's scientists talking to other scientists, engineers talking to other engineers through this vehicle of a peer-reviewed journal. It's how they advance knowledge in particular fields. It's how they brag a little bit. There's an aspect of bragging to peer-reviewed journals. And so there will be a section in every peer-reviewed journal article akin to the procedure section. And the purpose of that section is really two things. One is that if someone else wants to repeat it, they can do it by following description. Two is the reviewers of that article will look at the methodology used in the study and they'll say, yes, this is valid. This is a valid methodology to use to arrive at this conclusion. Or they'll say, no, the methodology is not valid, and so you cannot use it, and we're not going to publish this article because your methodology was not valid. So that's the purpose of it. We don't do this. The only time I might consider your procedure section to be invalid is if you wrote that you gave your tools and all of your equipment to some other group of students to do your exercise, and you're just using the data they produced to write the report. That would be an invalid method for your lab exercise. So, but generally what we're looking for is repeatability. So it's got to be sufficiently complete so that I could replicate your results. It's a narrative. It's never a numbered list. It's never bullet points. It's assumed to be in chronological order, so there's no first, second, third, fourth, then, next. It's a list of materials should be the first sentence, the materials used were, and then list the materials that you used. Do not list all of the materials that we list in the manual. Only list the materials that you used. And then your pictures of your hot air balloon should be in your data and observation sections labeled pictures in this section. The reader to go look at those pictures to understand what you're saying in your procedure section. It allows you to write a little bit less because you can refer to the picture and say, and essentially, go look at this picture to understand what was done. So use the pictures in this section. You can certainly do that. So this would be a sample of what a procedure section might look like. As you can see, the materials are listed first. Then there's a fairly detailed description of how this hot air balloon was made with reference to two illustrations of the hot air balloon that would be located in the data and observation section. And then, dimensions, the steps taken to create this thing, the number of paper clips put on it in one or two trials that were performed for this balloon. This is obviously not complete. This is just a sample of what it would look like. So that's what we're looking for in your procedure section. Now, data and observations, also written in the past tense. Every sentence in this section is written in the past tense. What you do in this section is you present your data. You do not analyze your data in this section, you simply present it. So you're going to have your pictures here. You're going to have a table for the competition results here. They'll be labeled like so. Figure 1, hot air balloon, period. Table 2, competition results, period. You do that so you can make reference to these things elsewhere in the report. Then you will discuss your balloon's trial results on its 1, 2, or 3 trials. Then you'll discuss the competition results, which means you're going to discuss the other balloons as well in the competition. And if you have pictures and discussion of the other balloons, or if you have pictures of the other balloons, you'll have some discussion of them here in this section as well. If you know the volume of the balloons, you would put the volume of the balloons here, right? So, bear with me for 1 second. So this would be picture of a balloon, figure 1, hot air balloon, comma, top view, period. Figure 2, hot air balloon, comma, side view, period, right? So you can make reference to those in the text by using this in parentheses or this in parentheses. This is your table. Obviously, this is not a table for the hot air balloon that's the subject here. This is just an example. And so you would have this table. Something to note about tables and figures. The label and caption on figures goes below the picture, like so. And then for tables, it goes above, like so. That's standard in peer review journals. So anything that's not a table is a figure, and so it would go below. So for all tables, it's going to go above like so. Everyone follow that? So this would be a sample, an example of a discussion in your data and observation section. So notice here that all that's happening is that the data is being presented, making reference to the picture, making reference to the other picture, making reference to the table, right? So the data for the hot air balloon that placed second, and the data for the other two hot air balloons is located here. I should quickly point out that the table I showed you is not the same data that you're seeing in this text here, and I didn't calculate the ratios. So if they're wrong, they're just wrong. This is just an example. It's not, certainly not something you should use in any lab report, but I use it just an example here. Right, so again, the pictures and the text, as you can see here, work together to create a single comprehensive whole. And in the data and observation section, you've got to discuss every competitor in the lab report. You cannot just discuss your hot air balloon, your robot, your vehicle, whatever it is you built. You've got to discuss all of the data in the data and observation section. Finally is your conclusion section, and this is where you analyze your data. It's going to be a mix of tenses. Obviously, if you're talking about what you did in the lab, that's going to be in the past tense. And then you're talking about changes that you might make to the balloon to improve its performance. That's going to be in the future tense, right? Then you're going to explain why your balloon won the place that it did, why the other balloons won the places that they won, and then what changes would you make to improve your balloon standing. To have that discussion about what changes you would make to the balloon to improve its standing, you've got to go back to this data, right? You've got to go back to cost, time afloat, and payload. And you've got to take a look at the data in each column, and you've got to figure out where you can improve and what you can change in these various columns to improve the standing of your hot air balloon. So as you can see in this particular exercise, the first place balloon, the third place balloon, and the second place balloon all cost 28 cents. So maybe you can change that. That might be kind of tough to change. It's hard to know. So then you would want to look at time afloat, and then you want to look at payload to make a decision about should your focus on altering something about the balloon to try and win the competition. Would you want to look at time afloat, or would you want to look at payload, right? So and then once you've decided that maybe one component is going to be your focus to improve your balloon's standing in the competition, you then have to explain what changes you would make in the design of the balloon to change that particular component of the ratio. Everyone follow what I'm saying here? So it's always the data that you look to when you're having these discussions in the lab report, because the data tells you what you have to change, what you have to fix in your particular design to improve its standing in the competition. So again, to talk about improvements to the balloon, you go back to the data, right? And your analysis in this section has to use that data as well, right? For this one exercise, for these three balloons, 1, 2, and 3, since they all have the same cost, you probably wouldn't look at cost very closely to try and analyze why your balloon placed second or why your balloon placed third. You might want to look at payload, and you might want to look at time afloat. And I think sort of the obvious point is that the first place balloon had the highest time afloat, which is the payload of 1 here, and a payload of 1 here. So it really comes down to this column. And so what second and third have to do is they have to increase their time afloat. And at that point, you might want to look at balloon volume, right? Because that might be the thing that makes a difference. So you've got to know your balloon's volume, and ideally you would know the volume of the other balloons. Everyone follow that? So that's the discussion and inclusion. So the works cited section should look like this. Wrong lab, of course. This should be lab 1C hot air balloon. My apologies. I missed that. You can have more than one source in this section. In fact, it's ideal to have more than one source in this section. But every source that is in this section has got to have an in-text reference to it. Has everyone been instructed on how to do that in their lab reports? Anybody not been told how to do that? Okay, so was that a yes? You've not been told how to do it? Okay. So, and then your lab notes go in original data only. I can tell you in my classes, in my sections, I don't want to see lab notes anywhere except in original data. I've been teaching this class since 2004. I have never seen a sketch in lab notes that's worth including in the main body of the report. With all due respect to you folks out there who are very good at hand drawing, they're just never good enough. So you really shouldn't include them anywhere but in original data. So if you do put them in original data, the TA grader will give you an extra point. So if it's important to you, you can do that. Put your lab notes in original data. The TA grader will give you that extra point. So these are some general notes. All of the illustrations in your lab reports have to be labeled. As I showed you before, figure 1, figure 2, table 1, colon with a caption, a period at the end of the caption. Then you've got to have the in-text references. There must be in-text references to the sources in work cited. All of your measures in your lab reports have to have units. Yes, sir.
Do you label the lab notes under original data?
I'm sorry, say that again, please.
Do you label the lab notes under original data?
Do you label the lab notes under original data?
Do you label? You can. If you're going to refer to them in your text, you can. It's up to you. I mean, if you're not going to use them in your text, then I wouldn't bother. But if you want to make reference to them in your text, you should. Does that answer your question? The lab reports must use the passive voice. I'm sure all of you have seen this, been told about this in your lab reports. If you're having a problem with the passive voice, I strongly suggest you go to the Writing Center at JAB 373. Do an hour-long session with the tutors there. They're very good. And they can get you up to speed on the passive voice pretty quickly there. You can also, I'm pretty sure that your writing consultants in your classes can show you that PowerPoint presentation that you were shown on the first day or the second session of your classes, and you can learn about the passive voice by reviewing that PowerPoint. Your report is an argument. It's not maybe this, maybe that on the one hand, on the other hand. It's an argument. You go into the lab, you perform an exercise, you come out with a body of data. That data supports a particular conclusion. You are arguing for that conclusion from start to finish in your lab report, right? Your data, your hot air balloon placed first because. That's the conclusion that you're arguing for in your abstract, in your procedure section, in data and observations, and in your conclusion, right? You are consistently arguing for that conclusion because that's the conclusion that the data supports. And again, the most important component of the lab report is your data, right? So that's what it is. It's an argument. I strongly suggest that you complete a draft of your lab report 48 to 72 hours before it's due. Set it aside for a period of time. Go back, review it. Make sure it says everything that you want it to say. You can have a friend or a family member review it. That friend should not be someone who's taking this class. Right? That can get you into trouble. Don't share your lab reports with other students who are taking this class either in your section or in some other section. But someone who's not taking this class can review your lab report for you and make comments on it. And then finally, for every lab report, you should read the assignment section in the lab manual and make certain that you're responding to the questions in the assignment section in your lab report. And what I tell my students to do in my sections is the following. Write the data and observations section first. So you're done with the lab, take your pictures, take the Excel spreadsheet that the TAs have supplied with you with the competition results in it, copy those and paste them into your data and observations section, put labels on them, put captions on them, write about them, right? Now you're going to write about your balloon, write about any modifications that you made to the balloon between trials if you did not do that in the procedure section. Then you're going to write about the competition results. You're just going to present them in data and observations, saving the analysis for the conclusion section. So now you've done everything that you need to do in the data and observations section, and now you also know what you have to write about in the other sections because your data tells you that. Your data says you've got to write about the following things in the other sections. So write your introduction, write procedure, write conclusion, and then finally write the abstract last. But again, I suggest you write data and observations first, right? Oh, and I'm sorry. Then, when you've written the data and observation section, go to the assignment section in the lab manual, highlight and copy the questions in there, then paste those questions into the section in your lab report where you propose to answer those questions. Everyone follow that? So you've basically created an outline for yourself by doing that. You probably want more than just that in an outline to be a complete outline, but that's a good start, is to paste the questions from your assignment section into your draft and have your data and observation section written first. Everyone follow me? Any questions about that? Okay. Now, these are some resources that are available to assist you. Obviously, specifications for writing your lab reports, the annotated lab reports on eg.poly.edu, the Writing Center, which I just mentioned at JAB 373. Your writing consultant in your classes is obviously available to help you during recitation, and you can certainly send an email to your writing consultant and say, can we meet before class, or can we meet after class, or can we meet at some other time to talk about my lab report and my performance. So feel free to avail yourself of your writing consultant and get some additional time with your writing consultant. And then, of course, well, this is not so relevant for what you do in this. Anybody in this class using a Mac, in this section using a, in this room, excuse me, using a Macintosh computer? Anybody writing on Google Docs and then saving your document as a Word document before you submit it? And how many of you had formatting problems with your lab reports? Okay, how many of you have been told you've had formatting problems with your lab reports? So if you work, we're really set up for PCs, I think. I think that's fair, right? And I think most people in the world use PCs. I know Apple computers are very fashionable, if that's the right word. But if you write in a PC or if you write in Google Docs and then you convert to a Word document, highly likely that after you submit, our software is going to alter the formatting in your lab report. You might see data disappear. If you've created an equation in equation editor, sometimes that data will disappear if you've done it in Google Docs. So the solution is really to use a PC. If you don't want to do that, and at some point in your careers you're going to have to do that, I'm telling you right now, I think I'm correct about this. I mean, that's down the road for you if you're using a Macintosh. But if you really want to do that, what I suggest you do is once you've finished your report, email it to yourself, go to one of the PCs in the labs on the 5th floor over in Jacobs, download the document, reformat it, send that reformatted document back to yourself, and that's the document that you submit on our website. That will generally solve any formatting problems that are created by using Google Docs, Pages, or a Macintosh computer. That assumes that you've given yourself sufficient time to go through that process, right?
All right, listen. So some of you are rumbling a lot because of this, but do know that that is actually the state of affairs, right? When you go into your respective industries, when you graduate, you're probably going to be working on PCs unless you're a CS major. And typically you'll be running Linux or some form of Starnix, right? Now, a lot of you are working towards a degree in an industry that works with sensitive information, right? Especially mechanical engineering majors. I see a lot of mechies go into HVAC, but I also see a lot of them going into defense, right? Working for Department of Defense and similar contractors. So when you go into industry with companies that deal with very sensitive information, you're probably not going to have access to the internet as you know it at work. So that means you won't have access to Google, so you won't ever use Google Docs because that network is not online. Right? So you have to work with programs that aren't, collaborative necessarily like that.
So everyone's going to buy a PC after today, right?
I would like to remind you, that the laptop requirements for entering this school requires you to be able to run Windows. You can buy a Mac, but it must run Windows.
Yeah, you can also partition your hard drive if you want to do that. You can partition your hard drive, put an OS operating system on it. You can put the latest version of Word on that, and that will solve some of these problems as well. I mean, if you really got to just stick with your Mac because you're loyal, you can do that as well. Yes? I think we need the quiet, please.
You could always use Microsoft 360. You can just download the free Microsoft software and use Word on Mac instead of buying a new PC. I mean,
So
it's not
here,
that hard.
how many of you are aware of NYU's Virtual Computer Lab? Okay, so if you go to the NYU website, you can find our Virtual Computer Lab. There are a whole lot of applications that are on the Virtual Computer Lab. Faculty are not allowed to use the Virtual Computer Lab. It's students only. It's discrimination, but, it's life. But you can essentially borrow the latest version of Microsoft Word from the Virtual Computer Lab. It doesn't end up on your machine. You're essentially borrowing it, but you can use it there. There's a host of other applications here. Is Project on this? Do you know?
No. Project is a poly-only thing.
Okay, so Project you can obviously get on the third floor.
So if you go on the manual, there's a page on the manual called Software Requirements. Those of you in my class already know, but if you read the Software Requirements doc that's on the manual, it has information on how you can get some of this software for free. So for being part of this class, we haven't sent the roster over to IT yet, but once we do that, you can go to the third floor at the laptop help desk, and you can get Project on your Windows PC. Microsoft Project is not available for Mac, unfortunately, right? Now, what she said earlier was correct. You guys also have access to Microsoft Office 365, right? So if you take a look at the software requirements page, there are instructions for you to log into office.com with your NYU Net ID, and you will be able to download a copy of Microsoft Office for yourself on your computers for free, and not just the online version.
Okay, yes?
So in case you did not hear that, the Open Lab computers also have Microsoft Project in case you cannot download that onto your computers.
Any other questions about anything we've discussed today, the presentation, lab reports in general? Yes, sir.
Repeat that
Wait for
one
the
more time.
microphone.
Repeat that.
We can't download Microsoft Project yet because you haven't sent out the rosters.
Yes. You cannot get Microsoft Project until we send over the rosters, which will probably happen later this week.
So
by next
Project is
week-
on the lab computers.
Yes, Project
Correct.
is on the lab computers.
Hang on, Joe. Whoa, 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 whoa.
All right. All right, y'all, settle down, settle down. Any other questions? We want to make sure we get all of them. All right, I think we're good.
What time is it?
1:12.
You're sure there's no other questions?
Yes.
Do you need to put the ratio for all of the designs in the abstract or just the...
Quiet, please.
Do you need to include the data for all of the designs in the abstract or just the ones adjacent to yours?
I'm sorry, I didn't understand the question.
Like in the abstract, you said to include the ratio of like the first and like of other teams, but is that for all designs or?
Correct. So understand this about the competition labs. Most of the labs in this class are competition labs. But this would also be true of, say, Lab 3, right? It is the comparison of the 3, 4, 5 balloons' best ratio, highest ratio, to the other ratios that tells you what happened in the competition, right? So you've got to put all of those in your abstract, not all your data, not time afloat, cost, and payload, just the greatest ratio for every competitor. Because if you go back when I told you it's about telling a story, the story of the competition is how every balloon performed. So you've got to give the highest ratio for every balloon. For Lab 3, which I think you're turning in this week, some of you may have already turned it in, it's the comparison of the robot with hard coding to the robot with sensors that tells the story of that lab. And it's not every piece of data about those two stories that goes into your abstract. It's the data that tells you which is the better robot as compared to the standards that you used. Does that answer your question? Any other questions? Sir?
Well, we don't have the other trials.
No, I'm not talking about, you wouldn't, no, I'm talking about the ratios.
We didn't enter the competition. We didn't have time.
Well, then you can't, then you have to say you didn't have time to do the competition.
But you did the other trials. There were like 4 trials for. So
Okay, quiet, please.
talk about what you can.
Right. Look, the basic rule is if you don't have the data, you can't talk about that data. But you say you didn't have sufficient time to enter the competition. So you have no competition results. Right? Don't fudge, don't make data up, but you have to disclose that, and you have to say we didn't have time, there was not sufficient time to enter the competition, so there are no competition results. Question over here.
For like the background information, how would you like put the formulas that were used for the competition? I mean, or whatever, like the background. How would the formulas be formatted?
I would do it in equation editor.
But like, how do like when you say like we say that the formulas used and make the formula?
Well, you're talking about hot air balloon, correct?
Like let's say like that. Yeah.
Okay, so if you remember in the lab manual, there's a whole series of equations there that tell you how to compute optimal balloon volume to get the most amount of buoyancy, and you can, there's another formula that allows you to compute what the payload would be with a certain amount of force on the balloon, that sort of stuff. If you used that material in designing your balloon, you would want to include those formulas in your introduction, and you would want to talk about their application in the exercise. Does that answer your question?
So basically just add the formulas, like don't just like list them, just like add them into the.
Well, look, you're only going to include them if you use them in your design, if they influenced you in your decision making. So if they did, then those that influence you in your decision making, you're going to want to put them into the introduction section, and you're going to want to talk about the role that they played in your design. Does that answer your question? Okay. Yes?
For Lab 3, if your team didn't enter the competition, but there was like a team that did, do we need to talk about the team that did?
I would, yes. Just one team entered the competition? Out of how many teams? Well, not much of a competition, but yes. I wouldn't. Yes. If there was no competition, you just say there was no competition. I mean, what else can you do? There was not sufficient time for there was a competition component to this lab exercise, but there was not sufficient time to complete the competition. I mean, that's all you can say. Yes. So if you didn't take pictures, you're just going to have to take the penalty. So the lesson is take pictures. Right? Get your phone out, take pictures. Yes. Yeah, so I'm sorry. The lab TAs told you that if it's less than a second, you get 0, is that? Well, that used to be a rule, and some TAs may think it's still a rule. I didn't hear you, I'm sorry. $0.999. Look, if the TAs did that, go to the manual. What?
Headed back to that equation question, in physics and other classes, when you type an equation in your lab report, you're also supposed to give it, similar to like figure 1, figure 2, you're supposed to label equation 1. Are we doing that in this class?
I tell my students to do that. I don't know what other writing consultants are doing, and then you should refer to it by that number in your text. But that's standard. What was just described here is standard in technical writing. So back to these gentlemen here. There was once a rule that said if your balloon did not float for at least a second, the time afloat was 0. Some TAs may still believe that that rule exists.
I do not know for certain if that rule still exists or not.
Well, it's not in the manual because I checked.
Okay.
Well, then you would say in your lab report, the TAs gave you this instruction. It's not in the manual, so it's incorrect. Then you would calculate your ratio, and then you would say, given this calculation, our place would have been X. Right? And then you complain to your professor and say,
yes,
we got stiffed because we were supposed to get first place and get those extra 10 points. What's that?
Would that be the sole exception of talking or mentioning the TA in your lab report? Because we were taught to never mention the TAs.
Who told you to not mention the TAs? You can mention the TAs. Look, folks. Think of the competition labs as a sporting event. Athletes routinely complain about the refs in sporting events. So if you think your TAs did something wrong and it had an impact on the outcome and you lost 10 points or 5 points or whatever it might be, you complain. You put it in your lab reports and you say, the TAs got it wrong and we lost 10 points. Yes?
Can I? Okay, I was actually going to add on to that. So we talked a little bit about professional tone, to not mention the TAs, in that you don't say, oh, the TAs gave us this, the TAs gave us that, right? But if the TA had an impact on the outcome of your lab, then you have to mention them, because how else are you going to let us know what happened?
Clear? Anything else? Okay. You're out of here.
Thank you.